Bismillahirrahmanirrahim. Assalamu alaikum. As we discussed in the previous video lecture that what is a polynomial, what are the linear factor, and what is factor theorem. So that background knowledge will be used to convert type A polynomial, which is p of z is equal to z square plus a square, where a is a real number, z is a complex variable, into linear factors, and type B polynomial, which is p of z is equal to a z cube plus b z square plus c z plus d. So a b c d from the set of real number, as z is a complex polynomial. So for type B polynomial we will use factor theorem to convert type B polynomials into linear factor, and type A polynomial, which is of the form z square plus a square, a may be any real number, such type of polynomials will be converted into linear factor by using the fact that you already know that iota square is equal to -1. So how I convert this into the linear factor? By using iota square equal to -1. So if I consider this is the type A polynomial, I am converting the type A polynomial into linear factors. So phi of z is equal to z square plus a square. So this can be written as z phi of z equal to z square. This is p of z is the representation for this polynomial because the variable here is z. In previous video lecture you see that we are denoting the polynomial by p of x. So if you see there, the algebraic expression which is a polynomial is actually dependent on x. The variable is x, that's why we are denoted that polynomials by p of x. Here the variable is z, so that's why this is denoted by phi of z. This can be written as, I am writing minus, this is iota square a square. You know that iota square is equal to -1, so this plus is converted into minus and minus. You know this plus is equal to minus multiplied by minus. So instead of this plus I am writing minus and -1 because this iota square is equal to -1. Then p of z, this implies that p of z is equal to, this is z square, this can be written as iota a whole square. So in previous video lecture you see that I explained in example number 1 that x square minus 1, p of x is equal to x square minus 1 can be factorized by using a square minus b square formula. So in this case if you see that this z square minus iota a whole square can be factorized by using a square minus b square formula. So a square minus b square is equal to a plus b into a minus b into a minus b. So this implies that p of z will be equal to z minus or z plus iota a into z minus iota a. Here the value of a is z and the value of b is iota a. So you see that your quadratic polynomial, which is this is a polynomial of type A. Remember we name this polynomial is polynomial of type A. This polynomial of type A is which is a quadratic, so it must be converted into two linear factors. So you see that this is converted into these two linear factors, these two linear factors. Z is your variable, a may be any real number, and iota is imaginary unit which is equal to square root of -1. So these are the two linear factors. So you will write the two linear factors of p of z is equal to z square plus a square or z plus iota a and z minus iota a. These are the two linear factors. So this is the procedure to convert the polynomial of type A into the linear factors of type A into linear factors. Now I am before to discuss the polynomial of type B, how we can convert this polynomial of type B into the linear factors. So we will use factor theorem. Before to discuss this, I am solving the exercise questions. The exercise question, now this is exercise 1.3 question number 2. you need to factorize the polynomial phi of z into the linear factors. I am considering part 2, which is of the type A. Type A is z square plus a square. So you see that this is type A, and part number 3, which is p of z is equal to z square plus 4. So these are the two questions in exercise of the type A. So how you can convert into the linear factors? If I take part number 2, so p of z can be written as the required is to convert these two polynomials into their linear factors. So both these two polynomials are of the type A, z square plus a square. So how you can convert this? This can be written as under the root 3 z whole square. So if when square come on the square root of 3, so you will get 3, and when it come on z square, so it will become z square. When it get on z, so you will get z square, and this will be written as, I can write like this. This is iota whole square. So you see that when the square come on the square root 7, so you will get 7, and when the square root come on iota, so you will get iota square. So iota square is actually equal to -1. So -1 multiplied by minus, you will get +1. So this thing is actually equal to 3z square plus 7. So you see that this is a square minus b square. So p of z is equal to, this is a, the value of a is this, so a plus b, by using the formula a square plus b, a square minus b square is equal to a plus b into a minus b, and this will be square root of 3z, this will be plus square root of 7 iota. So these are the two linear factors. So here you need to write that the two linear factor of this are this and this. Now if you see to part number 3, so part number 3, p of z is equal to z square. This can be written as 2 iota whole square, because 2 square is equal to 4 and iota square is equal to -1. So -1 multiplied by 1, so you will get +4. So you will use a square minus b square formula. So this is z plus 2 iota, and this is z minus 2 iota. So you will write here the two linear factors of, the two linear factors of p of z, which is z square plus 4, are z plus 2 iota and z minus 2 iota. So you see that whenever you have a polynomial of type A, mean the structure of that polynomial is z square plus a square. So you will use this area z square minus 1 to convert that into the linear factor. You see that I am convert that into linear factor by using this area, this fact. So this is the polynomial of type A. Now how you can convert the polynomial of type B into their linear factors? You see that this is a polynomial of type B. So how you can convert this into the linear factor? So we will use factor theorem for this to convert it into the linear factors. We will use the factor theorem. So how you can use that factor theorem? We discussed that in detail in the previous video lecture. If you see to the I am considering the example number 17, which is given on the page number 22 of the textbook. P of z, this is example number 17. P of z is equal to z cube plus 5z square plus 19z minus 25. Convert this polynomial, or the question is factorize the polynomial phi of z into linear factors. This is the question. So you see that this is the polynomial of type B. In type B, you see that this is the polynomial of type B. This is a cubic polynomial. Degree of the polynomial is 3. So you see that this is the example of the polynomial of type B. So how you can convert this polynomial into their linear factor, you will use factor theorem. How you can use factor theorem? Factor theorem says that x minus a, if p of x is your polynomial, so x minus a is a factor if and only if p of a equal to 0. But in this case you see that my polynomial is dependent on z. So if this is your polynomial, so z minus a is be your factor if and only if p of a equal to 0. So this f and only f contains both the direct and the converse part. If z minus a is a factor, then it must be true that p of a will be equal to 0. And the converse part is, if phi of a equal to 0, then it must be true that z minus a must be a factor. So this is the statement. So here I need to find a value on which this polynomial gives me 0. So z minus that value will be my first linear factor, and to find the other linear factors I will divide this polynomial by that linear factor and using the formula that dividend is equal to divisor plus multiplied by quotient plus remainder. So I will get the remaining two linear factors by factorizing that quadratic factor into the linears. So first of all, if I put here, let's say put z is equal to, let's say if I put z is equal to 1 in the given polynomial, so this will become 1 cube, this 5 into z mean 1, anywhere here replace z by 1, so this is 19 into 1 5, because in place of z I put 1, so anywhere there is z I will replace that by 1. So this is 1, this is 5, this is 19, this is 25. So you see that this is 20 plus 5 25 minus 25, you will get 0. So this implies that z minus 1 is a linear factor phi of z is equal to z cube plus 5z square plus 19z minus 25. So how I can find the remaining two linear factor? Because you know that the number of the linear factors are equal to the degree of that polynomial. So the degree of this polynomial is 3. So that's why I will divide this polynomial z cube plus 5z square minus 19z minus 25 by z minus 1. So this is a factor, so remember you will get a remainder 0. So let's say if I multiply it by z square, so that will become z cube, that will be minus z square, minus 1 multiplied by z square plus minus plus, so cancel, you will get 6z square plus 19z minus 25. So this is plus 6z, so this is 6z square minus 6z plus minus, this is plus, so this is 25z minus 25, so multiplied with 25, so you will get 25z minus 25 plus minus, this is plus, so you will get a remainder 0. So you know that this is your dividend, this is your divisor, this is your quotient, this is your remainder. So dividend is equal to, you remember that dividend is equal to divisor multiplied by quotient plus remainder. So in that case, z cube plus 5z square plus 19z minus 25 will be equal to divisor, which is z minus 1, into quotient, which is z square plus 6z plus 25 plus 0. So if you write plus 0 or not, it doesn't mean matter. So you see that this is your polynomial p of z. So p of z is converted into two factors. One factor is linear and the other factor is quadratic. And the question is, you need to convert the given polynomial into linear factors. So it means you need to convert this quadratic factor into linear factor. So it is a quadratic, so that's why this factor will be converted into two linear factors. this must be converted into two linear factor. Now we will do this by completing square method. You already know the method of completing square. Now what is the method of completing square? If I write this p of z, this is p of z, z minus 1. P of z mean you this is p of z, this is your p of z, this is the given polynomial which you need to convert into linear factor. So p of z is equal to z square plus 6z. I can write this 25 equal to plus 9 plus 16. I can write 25 is equal to 9 plus 16. So this is p of z, which is this is z minus 1. This is equal to, now I can write this is z square plus 2 into z 3. So from this you will get 6x, and this is 3 square, which is equal to 9, and this 16 can be written as minus 4 iota whole square. Now iota square is equal to minus 1, so minus multiplied by minus you will get plus, and 4 square is equal to 16. So this is z minus 1. Now in this step leave it, this is plus 16. So this is z plus 3 whole square plus 16. So here if you see, this is a polynomial of type A, z square plus a square. So this 16 can be written as 4 square, 16 can be written as 4 square, and here this is z square, z plus 3 whole square. So this is of the type A, and you know that type A polynomials are factorized into linear factor by using the fact that iota square is equal to minus 1. So this will be z minus 1, this can be written as z plus 3 whole square, and this can be written as 4 iota whole square, because iota square is equal to minus 1, so minus multiplied by minus you will get plus. So this is z minus 1, and that is a plus b whole square, a square minus b square formula. So this is a plus b, and this is a minus b. So you see that your given polynomial p of z is converted into 3 linear factors. So thus the 3 linear factors of p of z, p of z mean the polynomial which is given in the question, z cube plus 5z square plus 19 plus 19z minus 25. So p of z converted into 3 linear factors. The linear factors are z minus 1 comma z plus 3 plus 4 iota and z plus 3 minus 4 iota. So these are the 3 linear factors. These are linear because the highest power of the variable is 1. Z is your variable, so here the highest power of the variable is 1, here the highest power of the variable is 1, and here the highest power of the variable is 1. So you see that your given quadratic, your given cubic polynomial of type B is converted into the 3 linear factor because the degree is 3. So you first of all here we use factor theorem, and then when it converted into the product of two factors in which one factor is linear and other factor is quadratic. So when the polynomial become quadratic, so you will switch to the type A which you studied before the type B. So I use the procedure by converting the type A polynomial into linear factor by using this fact which we already studied in the beginning of this lecture. So this is the procedure to convert the type B polynomial into their linear factors. Type B polynomials are actually cubic, so it must be converted into 3 linear factors. Now switch to the exercise questions. You see this is the detail. If you want to write down all the details, so these notes are also available on the college website. You can write it from here. So now you see that we discussed the polynomial of type A, and this is the polynomial of type B. So how we can convert the polynomial of type A, this is explained here, which already discussed in the beginning of the lecture. Now we also discussed how we can convert the polynomial of type A into their linear factors. So these two parts are discussed here. This is part number 3, which is the polynomial of type B. So polynomial of type B, this is a polynomial of type B. So we will use factor theorem. We will use here, if you see, we will use factor theorem. We will use factor theorem. We will use factor theorem to convert this polynomial into linear factor. So first of all, I will think for a value on which the given polynomial is 0. So if I plug 2, so you will get 0. So z minus that value is a factor of this polynomial according to the factor theorem. So if I want to find the other two factor of this polynomial, you need to divide the given polynomial by z minus 2. Z minus 2 is a factor, so the remainder must be 0. So then use this formula, this relation, that dividend will be equal to divisor multiplied by quotient plus remainder. So you see that your polynomial can be written like, so you see that this is a linear factor and this is a quadratic factor. So if you want to convert the quadratic factor into linear factor, you must use the procedure that you used for the type A polynomial. And actually, if you see, this is a type A polynomial, z square plus a square. So this can be written as minus iota whole square minus iota square is iota square is equal to minus 1 minus multiplied, so you will get plus 1. So this is z minus a. Use the formula a square minus b square. So a plus b and a minus b and a plus b. So these are the three linear factor of this polynomial. This is the part number 3. Now if you see to part number 4, this is the assignment for you people, which already explained here. P of z is equal to z cube plus sec z plus 20 into linear factors. So first of all, you need to find a value on which this polynomial gives you 0. So that is z minus 2. If you put minus 2 here, you will get 0. So z plus 2 is one factor. Z minus a is your factor according to the factor theorem. So here the value of a is minus 2. So z minus 2 means z plus 2 is one factor. So then divide this polynomial by z plus 2. So you will get a remainder 0 because this is a factor. And the other quadratic and the other factor that you get is z square minus 2z plus 10, so which must be converted into linear factor by using the polynomial of type A procedure. So this quadratic is converted into this two linear factor. So two linear factor are here and one linear factor is here. So you see that 1, 2 and 3, these are the three linear factor of this cubic polynomial, which is of the type V. So this is all about the polynomial of type A and polynomial of type B, and the conversion of polynomial of type A into their linear factors and the conversion of polynomial of type B into the linear factor. For polynomial of type A, this is the brief revision. We will use this fact to convert such type of polynomials into their linear factors, and for such type of polynomials, which is polynomial of type B, into linear factors by using this. Remember that the degree of this polynomial is 2, so here will be 2 linear factors. The degree of this polynomial is 3, so here will be 3 linear factors. So this is the whole procedure. In this video lecture, we cover the question number 2 of exercise 1.2. Inshallah, in coming video lecture, we will discuss about the quadratic polynomial, quadratic equations, which will be discussed inshallah in next video. And in the coming video, the chapter number 1 will be also completed. Thank you.